So now that we've talked about how to solve systems of equations graphically and algebraically with 2 variables and with 3 variables, now what we're going to look at is how do we apply this to application problems. I'm not going to actually go through and solve the applications, but what I want to do is I want to just set them up and show you how you would create a system of equations using this scenario. And then, you would just use one of the methods that we've talked about to solve them. So first thing here, what we need to do is we need to read the problems, assign variables, reread the problems, and write a system of equations. And then what you would do is you would solve the system, make sure that you've answered the problem by writing your answer in a complete sentence, reread the problem, and make sure that your answer really does make sense. So those are just some strategies and some steps for solving application type problems. Let's go ahead and just look at this example. We're not going to go through all 6 steps, but we're going to go through the first 3 where we actually set up the system. So one number is 3 more than twice another number. Their sum is 9. We want to find the 2 numbers. So usually at the end of the problem, it's going to talk about what are you actually trying to find and what your variables should be. So we want to find the 2 numbers, which means we have 2 variables here. So we're going to let x equal one number and y is the second number, or the other number, so another number. So then we have to go back and we have to reread the scenario and try to write a system of equations. So since we have an x and a y, that really means I need 2 equations to be able to solve this. So one number, so x, is 3 more than twice another number. So 3 more would be 3 plus twice another, 2 times y. So there's my first one. X equals 3 more than twice 2 times y. Their sum is 9. So that means when I add them, I'm going to get 9. So x plus y is equal to 9. So this is your system, and then you would solve it using one of the methods. Looking at this system, since x is already by itself, the best way to solve this would be using substitution, because then you could just take the top equation, plug it into the other. So I'm not going to go through the solving, but if you want to, you can yourself. But we've already talked about how to solve it. So you can go back to the previous videos if you need to learn how to solve. So let's look at another example. Suppose 1,080 tickets were sold for a show for a total of $6,055. If adult tickets cost $7 and children's tickets cost $3.50, how many of each kind of ticket were sold? So again, look at that last sentence. How many of each kind were sold? There's 2 kinds, adult tickets and children's tickets. We want to know how many of each. So how many adult tickets, how many children's tickets, which means those should be your let statements. Those should be your 2 variables. X should be the number of one of the types, so let's say adult. So let X equal the number of adult tickets. And let Y equal the number of children's tickets. So what that means is, let's go back and reread the problem and see how this applies. So it says, suppose 1,080 tickets were sold. So that means there was a total number of tickets of 1,080. So that means X plus Y would have to be 1,080 tickets, since the number of adult tickets plus the number of children's tickets were 1,080. So I'm going to go ahead and write that down. X plus Y equals 1,080. So there's my first equation. Then I'm going to go back and continue reading. So suppose 1,080 tickets were sold for a show for a total of, so the total amount of money made was $6,055. Now, it goes on to tell us adult tickets cost $7 and children's tickets cost $3.50. So the total amount of money made with adult tickets and children's tickets was $6,055. The total amount of money made from adult tickets would be $7 times however many adult tickets you sold, right? If you sold 3 adult tickets, it would be 3 times 7, it would be $21 made from adult tickets. So 7 times X would tell me how much money I'm making from adult tickets. Children's tickets would be $3.50 times the number of children's tickets, which is Y. $3.50 times the number of children's tickets would tell us how much total money we made in children's tickets. And remember, the total with children's tickets and adult tickets added together has to come to $6,055. So that means 7x plus 350 times y equals $6,055. So the total in adults plus the total money made from children's has to equal the total amount of money made altogether. So this would be your system, and then you would go ahead and you would solve it. Now when you solve this system, I would recommend using elimination, because if you look, it's already lined up where it's an x plus y equals 1080, 7x plus 350y equals 6055. You could eliminate, like let's say you eliminate the x's by multiplying the top equation by -7. So it's already set up kind of for elimination. So let's look at a couple more setups. So example 3, GTE Wireless offers the following plans. For plan 1, the flat rate is $15 and the per minute charge is $1.50. For plan 2, the flat rate charge is $25.95 and the per minute charge is 75 cents. At how many minutes will the two rates cost the same amount? So I have two variables here. I have minutes and I have cost. So when we do this, let's let x equal the number of minutes, and let's let y equal the cost of the plan, because these are talking about like cell phone plans. So for plan 1, so the first plan, I have flat rate is $15. So it costs $15 plus however much you spend per minute, or how many minutes you talk, times $1.50. So it's $1.50 per minute. So what that means is plan 1, the total cost of that plan is going to be $15 plus $1.50 times the number of minutes that you talk. So it's going to be 150 times the number of minutes. And then for plan 2, it's going to be the total cost will equal $24.95 plus, because that's the flat charge, so the bottom charge or the initial charge, 75 cents per minute. So 75 cents times the number of minutes added on to $24.95 will be the total cost of that plan. So this is going to be your system, those two equations. Now, for this one, I would say use substitution since they both equal y. You just set them equal to each other. Take that 15 plus 150x and plug it in for y in the second equation. And then it just wants to know how many minutes will the two rates cost the same. So what would x have to equal when y is the same? So if you set the two equations equal, all you have to do for this one is find x. You don't actually have to find y, because it's not asking you for what the cost will be. It's not asking you for what y will be. It's just asking you for what will x be when the two y's are equal. So just keep in mind, make sure you always answer the question when you're doing these. Let's look at example 4. Example 4 says Amy has a total balance of $10,000 on 2 credit cards. One card has 6% annual interest and the other has 7%. If she is charged $630 in interest for the year, what is the initial balance on the credit card? So she has 2 credit cards. That's important. So we want to know the initial balance on each of the credit cards. So we're going to let X equal the initial amount, or initial amount on the 6% initial amount of card with 6% interest, and let Y equal the initial amount of the card with 7% interest. So she has a total balance of $10,000, which means on the 2 cards added together, the total is $10,000. So that means X plus Y, so the initial amount from each card has to total $10,000. So then it says she's charged with $630 interest. So on top of that balance of $10,000, she's charged with $630 in interest, which means we have to consider the 6% and the 7% interest on each card to get the $630. So that means 6% of however much is on the first card. So 6% as a decimal is 0.06 times the amount on the first card plus 7% of the second card has to equal $630. It has to equal the interest. So you're finding the interest on each individual card to get the total interest. So then this would be your system. And again, I would use elimination on this just because it's already kind of set up. And you might want to even convert this second equation. Remember, you can multiply it by 100 to get rid of those decimals. That might be a more convenient way to solve this. So let's look at a couple more. Example 5, we have how much 30% alcohol solution and 60% alcohol solution must be mixed together to get 25 gallons of 48% solution. So if you've done chemistry, this is probably a typical chemistry problem that you've seen with concentrations. You're trying to take a 30% concentrated solution and a 60% concentrated solution, and you're trying to get 25 gallons of 48% concentration of a solution. So what I need to do is I have 2 different types here. I have a 30% solution and a 60% solution. So I'm going to let X equal the amount of 30%. And since I'm talking about gallons, I'm going to say X will equal the gallons of 30% solution. So the number of gallons of 30% solution. And let Y equal the gallons, the number of gallons of 60% solution. So then we know the total number of gallons has to be 25. So the total number of gallons of 30% solution plus the number of gallons of 60% solution has to equal 25 gallons. The next thing though is to consider the percentages or the concentrations. So if you have 30% solution, so 30% would be 0.3 of the number of gallons of 30% solution plus 60% of the number of gallons of the 60% solution has to equal 48% of the 25 gallons. So that would be your system. You would set it up and solve it. Again, you can eliminate those decimals if you want by multiplying by 10 to move the decimals over, or you could even use substitution by rewriting one of the equations to get it by itself, get one variable by itself and plug it in. Let's look at one more example. So example 6, I have a collection of nickel, dimes, and quarters that consist of 15 coins with a total value of $1.10. If the number of nickels is one less than 4 times the number of dimes, how many of each coin is contained in the collection? How many of each coin? So I want to know the total number of nickels, dimes, and quarters. That means I have 3 things, which means I have 3 variables. So let's let x equal the number of nickels. Let's let y equal the number of dimes. And let's let z equal the number of quarters. So this is going to be a 3 variable system, which means 3 equations. So my first scenario is I have 15 coins total. So that means when you add all of these up, it has to equal 15 because there's 15 coins. The next thing talks about the total value. So the total value, so this means you're going to consider how much each coin is worth. So 5 cents times the number of nickels plus 10 cents times the number of dimes plus 25 cents times the number of quarters would have to equal their total value, would have to equal $1.10 because dimes are worth 10 cents, nickels worth 5, quarters worth 25. So you'd multiply the value times the number of each coin, and that would have to add up to equal the total value. And then the last equation is saying that the number of nickels, so that would be x, is 1 less than 4 times the number of dimes. So dimes are represented by y, so 4 times y minus 1 is going to get me the number of nickels. 1 less means you're taking 1 away from 4 times the number of dimes. So the last equation is x equals 4y minus 1. So that would be your system, and you would have to do that using the method that we learned in the last lesson where you write A, B, and C, you eliminate variables from A and B, same variable that you eliminate from B and C, so you get a 2 variable system, and then from there you solve for 1 variable and then start plugging back in. So again, you should try solving these on your own. I just didn't want to spend the time going through all of that. I wanted to worry more about the setup for this set of videos.